Hello viewers, in today's session we are going to discuss another important problem from Dirac delta function, right? So viewers, we have already discussed a lot about Dirac delta function in our previous videos, and we have already discussed a lot of problems related to Dirac delta function. So in this class we are going to solve this important problem in which we have to evaluate this integral involving the delta function. And remember here we have a function as an argument in Dirac delta function. So we have to evaluate this integral 0 to infinity, and here we have e raised to x sine inverse 1 over x, and the Dirac delta function x raised to 4 minus 1, right? So here we are going to utilize the definition of the delta function and one important property of delta function to solve this integral, in which we have a function inside the Dirac delta function, right? So here the argument is a function, and we'll see how we can solve these type of integrals. So now let us take this function as g of x, right? And let us take this function as f of x. So our integral now, it reads as 0 to infinity. We have g of x and delta of f of x, right? So now we have to first find the value of delta of f of x using the property of a delta function, right? So the property goes like this, that is delta of f of x is given by the summation I is equal to 1 to n, and here we have delta of x minus xi, and in the denominator we have the mod of f prime of x of I. So here this I, it runs from 1 to n, and it denotes the number of roots of the equation f of x is equal to 0. So this is the equation f of x is equal to 0, which has n roots, and here f of x is given by x raised to 4 minus 1. So first step is to solve this equation f of x is equal to 0. So we have x raised to 4 minus 1 is equal to 0, right? So now x raised to 4 minus 1 can be written as x raised to 4 minus 1 raised to 4 is equal to 0. And we can now write x square raised to power 2, and here we can write it like this. So now applying a square minus b square, we have x square minus 1, and here we have x square plus 1 is equal to 0. Now x square minus 1 can be written as x minus 1, x plus 1, and here we have x square plus 1 is equal to 0. So now we have x minus 1 is equal to 0, x plus 1 is equal to 0, and x square plus 1 is equal to 0, right? So here fx is equal to 0 is a fourth degree polynomial, right? So we have a fourth degree equation, and it has 4 roots. So from here we have x is equal to 1, from here we have x is equal to minus 1, and from here we have imaginary roots, right? So from here we have x is equal to plus minus iota. So we see that this equation has only two real roots, 1 and minus 1, and two complex roots, right? So what we will do, we'll neglect the complex roots, and here we have x is equal to minus 1, right? And if we see the limits, here we have the limits from 0 to infinity, right? 0 to infinity. And we can easily see that this minus 1, it does not belong to this interval. So x is equal to minus 1, it does not belong to the interval that is 0 to infinity. So we'll also omit this root x is equal to minus 1, right? So now we can accept here only one root, that is x is equal to 1. So we have only one root, x is equal to 1. So we can denote it by x1. So x1 is equal to 1, right? So here I runs from 1 to n. So in this case, I has only one value, that is I is equal to 1. So now this property, it reduces to delta of f of x is equal to uh, delta of x minus x1 and divided by the absolute value of f prime of x1, right? So here we'll ignore this summation sign, because we have only one value of this index I, that is I is equal to 1, right? So delta of f of x is now equal to delta of x minus x1 divided by mod of f prime of x1. So this is delta of x minus 1, because x1 is 1, and mod of f prime of 1. So now mod of f prime of 1 can be calculated by differentiating f of x. So f of x is x raised to 4 minus 1. So f prime of x is 4x cube. So the derivative of x raised to 4 is 4x cube, and the derivative of 1 is 0. So now f prime of 1 is equal to 4 times 1 cube, and this is equal to simply 4, right? So mod of f prime of 1 is equal to mod of 4, that is equal to 4. So now we have delta of x minus 1, and here we have 4. So let us now come to our integral. So our integral is now 0 to infinity g of x, and here for delta of f of x, we can now write delta of x minus 1 over 4, and here we have dx. So now we can take 1 over 4 outside the integral. We have 0 to infinity g of x and delta of x minus 1, and here we have dx, right? So now to move further, we'll make use of the definition of Dirac delta function, which says that minus infinity to infinity, and here we have g of x delta of x minus a dx. Then the value of this integral is equal to the value of this function g of x at this point. So we have g of a, right? So now see, here the value of a is 1, right? So a is 1, and g of x is e raised to x sine inverse 1 over x, and the value of this integral is now equal to the value of this function at this point, that is 1. So we have 1 over 4 g of 1, right? So now we can write 1 over 4, and g of x is this function. So we'll substitute x is equal to 1, here x, and here we have x, right? So we have e raised to 1 and sine inverse 1 over 1, right? So g of 1 can be calculated by taking x is equal to 1 in this function. So we have 1 over 4 e and sine inverse of 1, right? So we have 1 over 4 e, and sine inverse of 1 is pi over 2. So this is pi e over 8, right? 4 times 2 is 8. So viewers, this is how we can solve these type of integrals involving the Dirac delta function, and the value of this integral is equal to pi times e divided by 8.